Efficiency. This light bulb is an LED light bulb. It has all these little squares in it. Those are LEDs, and and it's very efficient, much more efficient than the light bulbs that I grew up with, which looked like that. This is a good light bulb, but it's inefficient, which means what? If it's less efficient at making light, what does that mean? Arnold? It's not what? It's not good? Okay, yeah, it's not good. Less watts. Okay, less watts of what? Of light. Less watts of light. Good. This light bulb gets hot. It's nice and warm, actually. You can use it to like keep from freezing in the winter. This one is less hot. It makes less heat. So more of the energy that you put in is transmitted to light. There's also these weird things. They were good, but only for a minute. So, efficiency is a measure of how much energy is wasted by a machine. That's really what it is. Now, wasted, does waste mean that the energy is gone? No. What does it really mean? Yeah, it's just you're creating some kind of energy that you don't need. Who decides what type of energy we want and what type of energy we don't want? You guys do. You decide what type of energy you want and what type you don't want. Sometimes you want heat, right? Like I have a little heater in my office. Shh, don't tell anybody. Oh, no, I've said it on video. And you turn the switch and the coil thing lights up, but it also creates heat, right? So in that case, I want to warm up my office, so I want heat. So my efficiency would be how much heat can I produce based on the energy put in. But if you're in a car, let's say, you want motion. If you have a light bulb, you want to create light. If you have a speaker, you want to create sound. And so any type of energy you're making that's not the type you want, that's kind of wasted energy. So we use a machine to do work, and some energy is always wasted. But this is not destroyed. It's just a form we don't want. And most often, it's heat that's being created, and that's the form that we don't want. So for an engineer, it's always about making less friction in the machine, so it creates less heat. These are all simple machines, and you can make them more efficient by getting them to create less heat. So you have screws and wedges and levers and pulleys. Okay. These are the two formulas. And these are, there's one up on the wall, the work out over work in is up there. So efficiency can be the work out over the work in. And it can also be the power out over the power in, the out over the pin, and the out over the win. And then if you want to make this into a percentage, you multiply by 100%. There's no units for efficiency, it's just a percentage. So higher efficiency is better. If there was a perfect machine, which there is not, it would be 100% efficient. Are you ever going to get a machine that is more than 100% efficient? No, cannot have it. If you get that answer on a problem, it means you switched these two. You did it wrong, and you have to flip it back over. So let's do a quick one here. Okay. If you have a lever, and you're going to be over here, so Kiana's here, and she's going to grab this thing, and she's going to pull it down with 75 newtons of force. And she's lifting a 50 kilogram weight. So she applies 75 newtons and the 50 kilogram object only moves 10 centimeters. She's moving 1 meter, and we want to find the efficiency of that lever. So we do the work out over the work in. The work we get out is the potential energy of this mass. So find the potential energy of this guy is going to be our MGH. So it's 50 kilograms. And sorry, I'm rushing because, and we'll make G10. And the height it rises is 10 centimeters, which is 0.1 of a meter. So that's just going to equal 50 joules. Okay? So that's what we're gaining here. We gain 50 joules of potential energy. That's our useful energy. That's what we want to create. Now she has to pull with 75 newtons over 1 meter. So how much work did she do here? It's force times distance. She pushed with 75 newtons over 1 meter. Sorry, it's getting hard to see. So she put in 75 joules of work. Is she 100% efficient? No. So we're going to use this formula here. We'll go to power right now. She put in 75 joules. She got out 50 joules. So my efficiency is 66, I think, 67. Around 0.67, which is equal to 67% efficiency. Sorry, that's really messy. But it's on video and I'll post the video. Have a great day, everybody. I'll see you next day for a review.